Good morning, guys. Anjani Kumar here, dealing instrumentation subject for final year electrical students. In the last session, we discussed about error analysis, right? So, what are the mathematical errors that you are getting in the instrument? We discussed. So, what is meant by error? Error is nothing but it's a deviation from measured value to the true value. We can call it as an error, right? From that, we discussed about what is percentage error, and after that what is fractional error, right? So how the percentage error can be calculated as a limiting error. We discussed if a manufacturer defines that percentage error, so that we can call it as a limiting error. If a user defines that percentage error, that we can call it as a relative error, that we discussed in the last session. And what are the different formulas for limiting error? To calculate the limiting error, what are the formulas? So limiting error is equal to full scale reading by true value into percentage of accuracy at full scale. If a percentage of accuracy at full scale, that we can call it as a guaranteed accuracy error. If a percentage error for a particular measured value, if a percentage of accuracy that can be defined for a particular value, for particular measured value, then we can call it as a limiting error. So there are different definitions for limiting errors, and we discussed all the formulas, and we derive some problems also. How you can get the limiting error, how you can get the absolute error. From that you can easily get the absolute error on all these things. So we solved some problems also, right? So if any person didn't understand, you should go through my last session, and definitely you'll grab grab the information what I said earlier about error analysis. Now in this session I'm going to deal about what are the theoretical errors. Definitely there will be a theoretical errors also present in the instruments. In order to measure something, definitely requires some error, right? So what are the theoretical errors present in the measurement system? We'll discuss here. There are three types of theoretical errors. So there are three types of theoretical errors that occur in a measurement or occur in an instrument itself. So those are, see my PDF. So with that I'll clearly explain. So this is a theoretical concept. That's why I'm going to use my PDF with me to explain more easier, right? So there are how many errors? There are three types of theoretical errors that are going to be present in any instrument. So those are, first one is a gross error, second one is a systematic error. See, the first one is a gross error, second one is a systematic error, and third one is a random error. Alright, so these are the three theoretical errors that are present in each and every instrument. First, we discussed about gross errors. So what is a gross error? So gross error means these are the errors due to the human mistakes. Alright, so those are errors due to the human mistakes, right? Human mistakes. For example, carelessness while taking the readings from the instrument, the human being will be a carelessness. So this is one of the factor to get these type of a gross error. So if you want to measure something, whatever the person who has to take the reading, it may be a wrong reading, definitely the result will get wrong. Alright, so first example of this gross error is nothing but carelessness. That means carelessness while taking the readings from the instrument. If you calculate the result from the readings, definitely you will get the error. And second one is the inexperienced user. That means if you take the meters, wrong meters, for suppose if you want to calculate 0 to, if you want to calculate the measured true value 10 volts, for that if you take 0 to 100 volts voltmeter, definitely you will have a limiting error should be very high. According to full scale, when you go to the full scale, my limiting error starts decreasing, right? So for the measurement of 10 volts, you have to take at least 0 to 50 volts voltmeter is better suitable. Alright, along. So it's very difficult. Definitely you will get some error while you take a 0 to 100 volts voltmeter for measurement of 10 volts. Right, so this is nothing but inexperienced user. He don't know what type of instrument he has to take for the measurement of measured value. Right, so first one is a carelessness while reading while reading the uh, while uh, while taking the readings from the instruments. See, so what is a gross error? Gross error means these are the errors due to the human mistakes, right? So what are the human mistakes? For example, carelessness while taking the readings. Definitely it will give an error. And the second one is inexperienced user, but that user, he don't know what type of instrument that he has to take to measure the unknown quantity. So with that, definitely you'll get an error. And the errors due to loose connection. If the instrument which is having some loose connections, if you take the readings, definitely definitely the instrument will lead some error. So these type of errors that can be called as a cross error. Right, so what is meant by gross error? Gross error, I'll explain 2 or 3 times, so better understand. Nothing is there, right? So what are the theoretical errors? There are 3 types of theoretical errors. First one is a gross error, systematic error, and random errors. So what is a gross error? The error due to the human mistakes. Right? So what are the human mistake? Carelessness while taking the readings, definitely produce an error. And after that, inexperienced user. That user, he don't know what type of instrument to take for the measurement of unknown quantity. It also reads some error. And after that, error due to loose connection. If the instrument which is having some loose connection, if you take the reading from the instrument, definitely the instrument will get errors, right? In order to avoid these type of a gross error, so what should you do means, you should have take a number of readings and take an average of that readings for in order to get the accurate result. Right, if a gross errors are present in the system, definitely you have to take more number of readings. So with that, you have to take average of the readings in order to find the unknown quantity. So one of the best way to eliminate the gross errors. So that's about a gross errors. All right, now we'll go for a systematic errors. Basically there are 3 types of systematic errors. There are 3 types of systematic error. So those are instrumental error, environmental error, observational error. So we'll discuss each and every error one by one. So what is this? What are the different types of systematic error? There are 3 types of systematic errors. The first one is the instrumental error, environmental error, and observational error. First we'll discuss about instrumental error. These type of errors, what is an instrumental error? So these type of errors are due to low quality of meters. The meter which is having a low quality, like substandard instruments, substandard material. So that whatever the materials that we are going to use in that instrument, those are low quality materials. Right? If you use these type of instrument, definitely you will get an error. So these type of errors we can call it as an instrumental error. Once again, I'll explain what are the instrumental errors. So these are the errors due to the low quality of instruments. Low quality means low standard materials used in an instrument. So these type of instruments will read errors. These type of errors we can call it as an instrumental error. So what are the instrumental error? So those are limiting error. So those are limiting errors. What are the instrumental error? They'll definitely ask a question. So could you explain what are the instrumental error? So you need to explain all these things. Instrumental error is a part of systematic errors. So what is the instrumental error? The errors due to the low quality of instrument. These type of errors will be developed in the instrument. So what are the instrumental errors? So those are limiting error. So in limiting error means the percentage error, the fraction, but the percentage error defined by the manufacturer itself, that we can call it as a limiting error. So this is also instrumental error. Alright, if you take 0 to 10 volts, if you want to measure at 10 volts, you have a voltmeter na 0 to 50 volts voltmeter na, the pointer starts moving, it will reach some instrumental error, whatever the instrument, If you use a low quality instrument, that will lead instrumental error. So that is nothing but a limiting error, right? You know what is a guaranteed accuracy error? So these are the examples for instrumental errors. So you need to explain each and everything one by one. So limiting errors means the percentage error defined by the manufacturer itself. We can call it as a limiting error. So what is a guaranteed accuracy error? We discussed earlier. So what is guaranteed accuracy error? What is meant by guaranteed accuracy? The percentage error defined by the percentage error accuracy that can be calculated from the full scale itself. Right? I already told that accuracy can be explained by the percentage, by the full scale value or a particular measured value. Right? If you explain the percentage accuracy from the full scale itself, then we can call it as a guaranteed accuracy error. If a percentage accuracy that can be explained for a measurement of something, so then we can call it as a percentage limiting error. We discussed all these things. If you have any doubts, go through the last sessions. You can clearly understand. Now, what is a loading error? Alright. What is a loading error? So I can explain loading error concept in the next session itself. Thank you very much.